The vegetable grower packages carrots in bags with a nominal weight of 5 kilos. The grower claims that the mean weight of all bags is 5 kilos, and a random sample here of 64 had a mean of 4.9 and a standard deviation of 0.25. Does this provide evidence that the mean has changed, or the mean is not 0.5? So we're testing 4.9 against a claim that the average is 5 of the population, and we're dividing by 0.25 divided by the square root of n, which is the square root of 64. That's going to give the 0.1, or minus 0.1 divided by 0.25 over 8, so the 8 goes on top. So minus 8 by 0.1, 0.8 over 0.25, and there are 32, 3.2 of those, I think. Let me just double check. Yeah, 3.2, and do a sketch with your work just to show the visual. Examiner sees this. 3.2, little arrow inside critical region. So blah de blah, therefore there is evidence to suggest that the mean weight is not 5 kilos. We could probably also create a 95% confidence interval here to show the same kind of thing. If we multiply 1.96 by standard deviation over root n, we're going to get the standard error of the mean. The mean being 4.96 of the sample. So 1.96 multiplied by 0.25 divided by square root 64 gives me 0.06125. So if we take our 4.9 kilos, add it on, we're going to get my mean here to be between 4.9 and then 6125. And on the other side, it doesn't matter, we're actually just asked about 5. It doesn't reach 5, but let's do the other side anyway. And that's going to give 4.8483875. And as 5 kilos is not within this 95% confidence interval, we could say that the mean has changed as well. So a couple of different ways to approach different questions. Question 10. ABC Ltd, sounds like a Michael Jackson song, is exploring the possibility of offering a new product to its customers, provided there is sufficient demand for products. The company randomly interviews 300 customers, and 200 of them said they would. 200 do whatever the company wanted. 2/3 is P, so 1 minus P. 1/3, straight away you're identifying the type of question it is by the information that you're given here. Population proportion. Estimate the population proportion of P customers. P of customers who will buy the new product, and we have our N here, randomly interviews 300 customers. So we have my square root of 2/3 times 1/3 divided by 300, and I multiply by 1.96. This guy is going to give me, so I type into my calculator the two numerators, 2 times 1, 2, divided by 3 is 9, 2 divided by 9 divided by 300. So if you do the square root of 2 divided by 9 divided by 300, and then just multiply your answer by 1.96, or just put in all the little options on your calculator, this should give you an answer of 0.053344. So I'll just leave it at 533. And now we have 2/3 as 0.66 0.67 if I'm taking 4 decimals. That was what we were testing this proportion. So I have to add on 533. It's going to get me to 72 exactly, I think. 71 and 33, it's going to get me to 0.72. And if I take away 533, I'm going to get to 6134. 6134.